A hurricane is more than a storm. It's a powerful and complex system that can cause immense destruction, but it's also a fascinating natural phenomenon that scientists study to understand the forces of nature. It's an intricate system of magnetic forces, similar to the nucleus of a living cell. Just as cells are the building blocks of life, hurricanes are the building blocks of weather systems. They form under specific conditions and follow certain patterns, much like the way cells operate within the body. The core, the eye of the hurricane, behaves like a liquid magnetic sphere, drawing in energy, just as a nucleus absorbs matter. The eye is calm compared to the surrounding storm, but it's the center of the hurricane's power. It's where the energy is concentrated and where the storm draws its strength. Around the eye, clouds swirl in layers, creating a magnetic field akin to a cell wall in biology. These layers are like the different parts of a cell, each with its own function but all working together to keep the system running. The clouds move in a circular pattern, driven by the forces at the hurricane's core. All winds repelling outward from the hurricane are pushed north by magnetic repulsion, while those drawn inward move south by magnetic attraction. This movement of air is what creates the powerful winds that can cause so much damage. The winds are like the blood flowing through the veins of the hurricane, carrying energy and momentum. This system powers itself, producing electricity, much like an electromagnetic perpetual motion machine. The energy generated by the storm is immense, and it can create lightning and other electrical phenomena. This self-sustaining system is what makes hurricanes so powerful and long-lasting. As rain surges and winds circle, the hurricane becomes a living entity, sustained by the forces that govern both nature and the cosmos. It's a reminder of the power of nature and the delicate balance that keeps our planet in motion. Understanding hurricanes helps us appreciate the complexity of the natural world and the forces that shape our weather and climate. Scientists have been studying hurricanes for decades, using a combination of historical data, computer models, and direct observation. By understanding how hurricanes form and behave, we can better predict their paths and prepare for their impact. This research is crucial for protecting lives and property in hurricane-prone areas. Preparing for a hurricane involves a coordinated effort from individuals, communities, and governments. It's important to have a plan in place and to take action when a hurricane is approaching. This includes securing property, evacuating if necessary, and having supplies on hand to weather the storm. The aftermath of a hurricane can be devastating, but it also brings out the resilience and strength of communities. Rebuilding efforts can take months or even years, but the support and solidarity of those affected can make a huge difference. It's a testament to the human spirit and our ability to overcome adversity. As our climate changes, the frequency and intensity of hurricanes are also changing. Scientists are working to understand these trends and to predict how hurricanes will behave in the future. This knowledge is essential for preparing for the challenges ahead and for mitigating the impact of these powerful storms. Education and public awareness are key to reducing the impact of hurricanes. By teaching people about the science of hurricanes and how to prepare for them, we can help save lives and reduce damage. Schools, community organizations, and governments all play a role in spreading this knowledge. Hurricanes are a global phenomenon, and international cooperation is essential for understanding and responding to them. Countries around the world share data and resources to monitor and study hurricanes. Advances in satellite technology and weather monitoring systems have greatly improved our ability to track and predict these storms. The future of hurricane research holds great promise. New technologies and innovative research methods are being developed to improve our understanding of these powerful storms. Scientists are working tirelessly to find new ways to predict and mitigate the impact of hurricanes, making our world safer and more resilient. In the end, hurricanes are a reminder of the incredible power and beauty of nature. They are a force to be respected and understood. By studying hurricanes, we not only learn about the storms themselves, but also gain a deeper appreciation for the natural world and our place within it. Warm ocean water is the fuel that powers hurricanes. When the surface temperature of the ocean reaches at least 26.5 degrees Celsius, it provides the necessary heat and moisture to start the formation of a hurricane. This warm water evaporates, rises, and cools, releasing latent heat that powers the storm. The Coriolis effect, caused by the Earth's rotation, is crucial in the development of hurricanes. It causes the storm to spin and helps organize the system into a cyclonic structure. Without the Coriolis effect, hurricanes would not be able to form or maintain their structure. The eye of the hurricane is surrounded by the eye wall, a ring of intense thunderstorms that produce the strongest winds and heaviest rains. Beyond the eye wall are the rain bands, spiraling bands of clouds and storms that extend outward from the center. These rain bands can produce heavy rain and tornadoes, adding to the hurricane's destructive power. Historical hurricanes like Katrina, Andrew, and Maria have left lasting impacts on the regions they struck. Hurricane Katrina in 2005 caused catastrophic flooding in New Orleans, while Hurricane Andrew in 1992 devastated parts of Florida. More recently, Hurricane Maria in 2017 caused widespread destruction in Puerto Rico. These events highlight the importance of understanding and preparing for hurricanes. The aftermath of these hurricanes has shown the resilience of affected communities and the importance of global cooperation in disaster response and rebuilding efforts. By learning from past hurricanes, we can improve our preparedness and response strategies, ultimately saving lives and reducing damage in future storms.